Have you ever stopped to think about how your phone knows to dim its screen or how your car knows when it starts to rain? The answer is this incredible invisible network of technology that's all around us, constantly taking the pulse of the world. So today, let's dive in and demystify this unseen world of sensors. All right, here's the game plan for this explainer. We're going to start by defining what sensors are and how they're different from a related gadget called a transducer. Then, we'll get into how we actually grade their performance. After that, a quick tour of the most common types, we'll see how they all work together in a bigger system, and finally, we'll take a peek into the future. Okay, so let's pull back the curtain on these fundamental building blocks. These things are the hidden components in pretty much all the technology we interact with every single day, usually without even thinking about it. I mean, really think about it for a sec. How does your thermostat know when it's time to kick on the heat? How does your smartwatch keep track of your steps? How does any smart device actually get to be, well, smart? The answer to all of that lies in this hidden world. These two key components, sensors and transducers, they're the silent heroes that give all our devices a real awareness of what's going on around them. So what is a sensor really? Well, at its core, you can think of it like a detective. Its one job is to detect or measure some physical thing, like temperature or light or motion, and then respond to that information in some meaningful way. Now, let's meet its very close cousin, the transducer. A transducer is basically a converter. Its job is to take one form of energy and just transform it into another. A perfect example is a microphone. It's a transducer that turns sound energy into electrical energy. Okay, so here's the really crucial point. A sensor detects a change, while a transducer converts energy. And what's super interesting is how they're related. See, every single sensor has to have a transducer inside it. That's how it converts what it's sensing, like heat or light, into an electrical signal that a computer can actually understand. But, and this is key, not every transducer is a sensor. Think about a light bulb. It's a transducer, right? It converts electricity into light. But it's not sensing anything. So now that we know what they are, how do we know if a sensor is actually any good? Let's jump to our next section and see how we grade them. We're going to look at the key parameters that really define their performance. The best way to think about these parameters is like a stat sheet for an athlete or maybe a report card for a student. They tell us exactly what a sensor is good at and maybe where its weaknesses are. This is exactly how engineers decide which sensor is the right one for the right job. First up is accuracy. And this one's pretty straightforward. Accuracy is just how close the sensor's measurement is to the real actual value. So if it's actually 72 degrees outside, an accurate thermometer is going to read 72 degrees. Simple as that. Next, we have precision. Now, this one gets confused with accuracy all the time, but they are very, very different. Precision is all about consistency. If you measure the same thing over and over, how close are those measurements to each other? That's precision. And this target analogy just illustrates the difference perfectly. Accuracy is hitting the bullseye. Precision is hitting the exact same spot over and over again. So you can probably see how a sensor could be incredibly precise, hitting the same tiny spot every time, but not be accurate at all if that spot is way off in the corner and not the bullseye. Okay, a few other key stats help round out the report card. There's sensitivity, which is how well it can pick up on tiny changes, like a motion detector catching the slightest movement. Then you've got selectivity, which is its ability to ignore all the background noise and just focus on the signal it's supposed to. And finally, resolution is the absolute smallest change that the sensor can possibly detect at all. All right, so we know what sensors are, we know how to grade them. Now for the fun part. Let's go on a quick tour and meet some of the different specialists you'll find out there in the real world. First, let's talk about the optical sensor, like a photodiode. You can basically think of this as the sensor's version of an eye. It takes in light and converts that light into an electrical current. You've got these in your phone's screen to adjust the brightness and in automatic doors to see you when you approach. Next up are thermal sensors, like the kind you'd find in a thermostat. These devices have this really cool property where their electrical resistance, basically how easily electricity flows through them, changes with the temperature. So by measuring that flow, the system can figure out the exact temperature. Then we have magnetic sensors, and a common one is the Hall sensor. These guys are designed to detect the presence, the strength, and even the direction of magnetic fields. They're totally crucial in a ton of automotive systems, like for detecting wheel speed for your anti-lock brakes. Capacitive sensors are the magic behind your phone's touchscreen. The screen generates this stable electric field, and since your finger is conductive, it messes with that field when it gets close. The sensor sees that disruption and registers it as a touch. Pretty cool, right? And finally, let's look at the piezoelectric transducer. This one is seriously cool. There are certain materials that actually generate an electrical charge when you squeeze or press them. This effect is used to measure changes in pressure, force, or even vibration. It literally turns physical stress directly into electricity. The sensor that deploys an airbag in a car crash, that's what this is. So, we've met all the individual players, but the thing is, sensors don't work alone. Let's go to our next section and see how all these parts come together to create a complete, intelligent system. The whole process pretty much works like this. Step 1, something in the physical world changes. It gets hotter or brighter or something starts moving. Step 2, the sensor detects that change. Step 3, the transducer that's inside the sensor converts that detection into an electrical signal. And finally, step 4, the brains of the device, the wider system, processes that signal and decides what to do, like turn on the AC or switch on a light. So that's pretty much how it all works. These tiny, often completely invisible devices are what make our modern connected world possible. And that brings us to our final question. What does the future hold? We've given our world the power to sense temperature, light, motion, and so much more. This technology is only going to get more woven into the fabric of our lives. So the real question isn't if our world will get smarter, but how. As we keep building this incredibly connected future, what new senses should we give our technology? What kinds of problems could we solve if our devices could see or hear or even feel something that they just can't right now? That's the future that sensors are going to help us build.